Everybody, welcome back to Science of Science. One stop for all your educational videos for sciences, maths, and recently we have started with English as well. So the topic for today is differentiation. We have already uploaded few videos on formulas and concepts of differentiation. Today we will be discussing. Today onwards we will be starting off with question series of differentiation, where we would be dealing with many important questions from NCERT book, other book, previously asked questions, then some HOTS questions, etc. So the first question is one from your NCERT only, and it's a good question. So let's begin. The question states you have to find dy by dx when y is tan inverse 3x minus x cube 1 minus 3x square. Okay, this is your question. I hope the question is clear. So what let's do is, let's first write y again, okay, from the question only, because that's the first step. Always write your function which is given in the question. Tan inverse, just a second, 3x minus x cube upon 1 minus 3x square. Okay, this is the question. Now in this kind of a question, this is actually differentiation using inverse trigonometry, which we cannot directly solve using the formula for tan inverse. It will become very complicated. We first have to simplify this whole bulky expression, then only we can put the formula for tan inverse as differential, because this is otherwise going to be very difficult to solve such a big expression. So what let's do is, let x is equal to tan theta. Okay, now why I have put x as tan theta, you will understand when you see this expression. Again, look at this expression. You would find that suppose put this 3 tan theta minus tan cube theta 1 minus 3 tan square theta. This from class 11 you should know is the formula for tan 3 theta. And we already know whenever we have tan inverse outside, our aim is to make tan or cot inside, so that the inverse and the function gets cancelled out. Of course, we don't show the cancelling, but the effect is a cancellation and we get a simple expression. So our agenda here is to get a tan, and we can directly see that the expression which is given in terms of x, if we put x as tan theta, we get directly a formula for tan theta and our expression gets solved. So let x is equal to tan theta. So what your y will be now? Y is equal to tan inverse. We are just solving the inverse trigonometry. We have not started differentiation at all. 3 tan theta minus tan cube theta. The class 11 formulas are very important, otherwise you will never be able to solve this using this method. 1 minus 3 tan square theta. So this is the formula for tan 3 theta. So this becomes y equals to tan inverse tan 3 theta. Okay, and inverse and theta always have a cancellation effect. We will not show this cancellation effect, okay, because it's not a cancellation, but the effect is cancellation. But on paper we can't show it. This is the bad luck. Okay, so just write it as tan inverse and tan gets cancelled, so y becomes 3 theta in the end. So y is equal to 3 theta. And now you have to just come back to the first step which you had done. As you have written x is equal to tan theta, then what is theta? Because we have to put a value of theta, put the tan here, then you get theta, and whenever a trigonometric function changes its sign, its side, it becomes a inverse trigonometric function. So then you will write theta is equal to tan inverse x. Okay, that's the value of theta. Now I will put the value of theta in the expression which I have. So therefore, okay, let me just take up the red color. Y is equal to 3 tan inverse x. Okay, now I've got a very simple expression. I can directly differentiate it using the formula of tan inverse x, which we have done in our formula list video. You can watch that. It's just a 2-minute video and all the formulas of differentiation are covered. So now let's differentiate. Dy by dx is equal to, 3 is a constant, it is outside, into the differentiation of tan inverse x. Okay, so dy by dx finally turns out to be 3 upon 1 plus x square. How did it come? Differential of tan inverse x is 1 upon 1 plus x square. This is the formula for differential of tan inverse x, and 3 gets multiplied, so this becomes 3 upon 1 plus x square is the value for dy by dx. Okay, this method in which we have put theta as something else is called the substitution method, trigonometric substitution. Why was this method required? Because this method was required, otherwise this expression which was here, the 3x minus x cube expression, which was very lengthy, and differentiating it would not have been such easy. So that's why we have decided to take such an expression whose differential is easy for us. Okay, let's write the next question now and try to solve it up. So this is a question from R.D. Sharma. Okay, it's important as a 2 marker. The question is, I'll write it down. I have not taken the screenshot. Question 11 is e to the power x sine x sine x is equal to y, and you have to find out dy by dx. Okay, it's a good 1 marker. Now e to the power x sine x is the expression for y. Okay, so let's differentiate it. Now you know that e to the power x is a function and sine x is another function. So when there are 2 functions getting multiplied, use your product rule, which states that the dy by dx will be e to the power x into derivative of sine x plus sine x as it is into derivative of e to the power x. As you have a plus in between, if you write this term first or this term first, it doesn't matter, this or this. Okay, it doesn't matter. So e to the power x as it is, derivative of sine x is cos x, plus sine x as it is, derivative of e to the power x is e to the power x. All these formulas have been discussed in the formula list video. It's just a 2-minute video. Please do watch that, and of course do not forget to like it as well, and this one as well. So this becomes e to the power x. So finally what I can do is I can take up the e to the power x as a common. Okay, I can take e to the power x as common, and this becomes cos x plus sin x. Okay, is the answer for your dy by dx. Okay, alright, let's move to the similar question. The next question is very similar to this, but it's solved with a different method. Let's write the question with blue. The question is, just a second, oh by mistake I wrote question number 11. This is going to be like this. Okay, so question number 3 now for today is e to the power x sine x. So in the previous question we had, just a second, this is looking little untidy, I'll just make it a bit tidier. Okay, in this question, this is the question e to the power x sine x. In the previous question you had e to the power x into sine x, and now the power of e is only e to the power x sine x. So there is no need of product rule. You can directly use the chain rule here for differentiation. So let's use the chain rule and write as y is equal to e to the power x sine x. Okay, the sine x is in power, so dy by dx, e to the power x sine x as it is. Okay, the derivative of e to the power x sine x is e to the power x sine x. Exponential function has the same derivative, into the derivative of x sine x, because x sine x is not a standard function. You cannot just keep it out. Standard function is x, so you can't just keep out x sine x. You have to differentiate it as well, x sine x. Okay, I have done differentiation here also, but the answer for differentiation is same. Okay, that's why I have directly written it. So this becomes e to the power x sine x. Now x and sine x both are functions, so you have to use the product rule. So use it, and you will get here x as it is into derivative of sine x plus sine x as it is into derivative of x. This is what you get. So this becomes e to the power x sine x into x, derivative of sine x is cos x, so this is x cos x, plus derivative of x is 1, so this becomes just sine x, and this is your final answer for dy by dx. Okay, that's our final answer. So just see how can I modify the expression and the derivative completely changes is a mystery, and it's very interesting as well. So I hope the question is cracked. Okay, if it is, please put a like in the chat box, in the comment section. Okay, the next question number 12. We are discussing mainly 1 and 2 markers today, and MCQs, fill in the blanks and all. And these questions sometimes are also asked in your JEE to just test that you have not forgotten the basic methods. We will be continuing many more videos in this series, okay, for questions. And slowly as videos will progress, we will move to the tougher questions. Okay, sine inverse x cube is the function. I have to differentiate it. So let's begin. So first of all, again this question can be only cracked using the chain rule. So this will be dy by dx is equal to derivative of sine x cube, the whole function, sine inverse x cube. Okay, this whole function first, into the derivative of what? X cube. Because x cube, again, x is a standard function, x cube is not a standard function, we have to differentiate it. Now sine inverse x cube, what is the derivative of sine inverse x? Sorry, this is sine inverse x, we have to differentiate. What is the derivative of sine inverse x? The derivative of sine inverse x is equal to minus 1 upon under root 1 minus x square. Again, this is a formula, it's done in the previous video. Derivative of x cube is 3x square, okay, into 3x square, because this x cube can be written as x to the power n, and derivative of x to the power n is nx n minus 1. From that you get it as 3x square. This is the power formula, and just write the 3x square here, you will get the final answer. Minus 3x square upon under root 1 minus x square is the derivative of this function. Okay, we'll take up 2 more questions. Each video will be covering 5 to 6 questions. Some videos in which questions will be very interesting, we'll cover 7, 8 as well. The next question is a very easy question. So just to give you a pause from tricky questions, we can move to this easy question. This is our question. X square plus x plus 1 to the power of 4 is y. You have to find out dy by dx. It's very simple. So first of all, again use the chain rule. Dy by dx is equal to, first of all, you can see this whole expression. You can consider this expression as a. This is just for simplification, otherwise also it's a very simple question. So y is equal to, I can just modify at y is equal to a to the power 4. Now a to the power 4 means 4a cube. Okay, 4a cube is a formula for a to the power 4. So this will be 4 into a. What is a? X square plus x plus 1, which is a whole cube. But you can see as here a is not a standard function, it is x square plus x plus 1. It is a polynomial function. I have to differentiate this as well. So into the derivative of x square plus x plus 1. Okay, so this becomes 4 of x square plus x plus 1 whole cube into derivative of x square plus x plus 1. X square will be 2x, again using the power formula. X is 1 and 1 is 0. So this becomes 2x plus 1 is the final answer. Okay, should I write it once again neatly? 4 into x square plus x plus 1 whole cube into 2x plus 1 is the derivative, which is your dy by dx. That's it, question killed. We move to the next question and the last question for this video. The question is, one second, I'll just want to see which good question we can do, because I have a list of many questions actually, and I wanted to take the best question which is there. Okay, the question is x minus y is equal to pi. This is the question. Okay, x minus y is equal to pi, and you have to find out dy by dx. This is the question. This is another NCERT question. It's a very good question. So what we can do here is we can directly differentiate all the terms, because this is an implicit function. If you would observe, it is an implicit function because I cannot express x in terms of y completely or y in terms of x. I have this pi here which has to be included for x and y both. I can write x as pi plus y. I cannot write it independent of pi. I have to use pi. Or I can write y as pi minus x. Okay, minus y as pi minus x, so y is equal to minus pi plus x or x minus pi. Okay, all this can be written. So I cannot actually directly express x in terms of y or y in terms of x, and such functions are called implicit functions, where you cannot express one function completely in terms of another function. You have to involve a third function. The third function here is pi, and that becomes an implicit function. I'll write the name. Again, this has also been discussed in the formula video. Okay, so this is an implicit function. So now what we can do for this implicit function is we have to differentiate all the terms. Then only we will be able to crack this implicit function. So let's do the differentiation at all the terms. Okay, x का differentiation is 1. We are differentiating with respect to x. We can only differentiate with respect to one variable. Differential of y is also variable, is also 1, but it is differentiation with respect to x. So along with y, I have to write 1 dy by dx, or just dy by dx. Pi is a constant, it becomes 0. Why have I written dy by dx here? Because I am differentiating with respect to x, and this is y. So I have to write it is with respect to x. This has to be shown, and from here only you will get dy by dx. So 1 minus dy by dx is equal to 0. So what is dy by dx? Minus dy by dx is equal to, take 1 on that side, minus 1. Minus minus gets cancelled. So you get dy by dx is equal to 1. By writing this dy by dx with y only, I can introduce this dy by dx term here. Otherwise, so dy by dx term was nowhere. How would I have introduced that term only? Okay. So similarly, suppose I'll just give you an example to prove this, how to introduce. You have this question, w plus v is equal to 3. This is a question I have to find dv by dx. Okay, I have to find dv by dx. So that means dx by dv. Dx by dv I have to find. Suppose I have to differentiate, so I'll simply write it as I have to differentiate it with respect to v. Okay, differentiate it with respect to b. That is what I have to do, differentiate with respect to b. So what I need to do is, I will differentiate it as w is 1, it's a variable, derivative of w is 1. This is going to be dv by dx, dw by dv plus 1 is equal to 0. Why am I including this dw by dv here? This is because I am differentiating it with respect to b, and this is w. Whenever you have to differentiate with respect to another variable and there is another variable involved, you have to cancel it out in some way, or just write it as dw by dv. The same thing we have done it here as well. Okay, with this we end the class. Do stay subscribed. There are soon many more videos coming on such questions, and the playlist for these videos will be differentiation super questions. Okay, so please watch them and subscribe the channel as well. Thank you.